So in radiology, there's different technologies that we can use to image the human body, and in our case, the brain. The most commonly studied technologies for studying the brain are going to be MRI, which stands for magnetic resonance imaging, and PET, which stands for positron emission tomography. What MRI does is it uses a very powerful magnet as well as radio frequency waves, the same kind of radio frequency waves that you listen to your car radio on, for example, to generate images of the human body. It's very good at showing structural information about the brain. There's essentially no preparation except maybe letting us know what kind of metal or electronics that you might have in your body. If you have something implanted, it's important that you find out what's the make and model of that implant so that we can look it up and make sure that it's MRI safe. Once you get to the MRI check-in area, we'll ask you to take all electronics and metal out of your pockets. Anything that can be removed should be removed, and we'll change you into a hospital gown for the duration of the scan. PET has the advantage of showing where specific molecules are being taken up by the brain. That's why PET imaging is also often known as molecular imaging. For PET, what we do is we inject a radioactive tracer into the body. This radioactive tracer usually decays pretty rapidly so that you're no longer radioactive after a short period of time. This radioactive tracer is taken up by different tissues in the body, and that lets us generate images of the brain through a different mechanism. The more information we gather about using these techniques, both in healthy and unhealthy brains, symptomatic and unsymptomatic brains, the faster we'll be able to get to an answer about how these can help patients who are exposed to trauma or stress.
The image processing core develops and applies computer algorithms to help extract information from medical images that are acquired through MRI or PET. So CNRM was one of the first installations of a simultaneous PET MRI scanner within the United States. So our group has developed a patent-pending procedure to actually see missing connections perhaps, or shortened connections. And then there's also a large number of quantitative measurements that characterizes how well connected different regions within the brain are connected to each other. And we can compare that across individuals, between healthy individuals and unhealthy individuals, and see what the differences are. So if there's a healing process or repairing process, we can monitor that, especially if there's a therapy that's being administered to the patient.
Please visit our website at cnrmstudies.org. Subscribe to our Facebook page, Twitter feed, YouTube channel, and Instagram. That's where you'll have access to TBI and PTS resources. Please give us a call. We would love to hear from you. Together, we can make a difference.